Yeah, thanks for coming to my talk. I think it's always having the first talk after lunch break is always a challenge, but I'll try to make this as entertaining as possible. So I will be talking about Bluetooth LA audio broadcast today and how you can build an Auracast assistant app with Flutter. But before diving into the topic, a few words about myself. So my name is Eduard Siewert. I'm a software architect, and I joined this company Sennheiser in 2017. Some of you might have seen or even own a headphone from us. Maybe you can also see we also do mics, or at least the people in the first row can see it. I actually joined as an embedded software developer in the company, so I did the firmware on the headphones. After 1 or 2 years, I transitioned into mobile development, and that's also when I first got in contact with Flutter and have been using it since 2020. In 2022, actually, the Sennheiser consumer business got acquired by this company called Sonova. Sonova is one of the leading companies in the hearing aid industry. So yeah, that's why you see the Sonova logo on the top right of my presentation now. Okay, but before I start talking about Auracast, I would really be interested to know how many people actually know about Auracast or heard about it before joining this talk. So maybe can everybody raise a hand who has heard about it before? Okay, not so many. That's almost what I expected, but I hope you're gonna know more after this talk. So yeah, the question is, what is LA Audio Broadcast or Auracast, as it's the marketing name that's used by the Bluetooth organization. If you go onto the website of the Bluetooth Special Interest Group, which is the organization that is defining or developing the Bluetooth standards, you will read something like this. Auracast Broadcast Audio is a new Bluetooth capability that will deliver life-changing audio experiences. It will let you share your audio, unmute your world, and hear your best, enhancing the way you engage with others and the world around you. Nice. That's pretty fluffy marketing talk, I guess. I'm not sure if anybody of you is any smarter now. So I'll just try to explain it in my own words. So as the name broadcast already implies, in contrast to the usual classic Bluetooth connection that most of you know from connecting your headphone to your phone, for example, this is a one-to-one connection, which is bidirectional, so you can stream audio in both directions, so you can listen to the audio, but you can also have a mic and have a back channel. In the case of a broadcast, it's a different story, so you have one transmitter that is broadcasting the audio signal, and you can have an unlimited amount of receivers that can listen to this broadcast, just as you know it from a radio, for example. And this is also unidirectional, so there's no back channel. So the transmitter doesn't even know anything about the receiver. And this enables a lot of new and interesting use cases, actually. And one of them could be, for example, a silent screen, as you know them in the gym or a bar, where you have a TV on the wall and you want to hear the audio. So if this TV is Auracast capable, you can just, and your headphones, of course, as well, you can just put in your headphones, synchronize to the broadcast stream without having to do through a pairing process or any of these things. So it's very convenient as a user. Another example could be tour systems. So imagine you have a tour guide in a museum or something that is talking into a microphone, and then this audio signal gets broadcasted to everybody in the group that is wearing a receiver. Another example could be multi-language support. Imagine you being at a conference and the content is translated into multiple languages simultaneously, so you could just pick the language that you like and get it streamed into your headphones directly. Or situations of assistive listening, so being for example, in a large classroom in a university or at the airport, at the train station. Imagine you being at the airport and you don't want to miss your gate announcements. You can just synchronize to this gate announcement stream. You can continue listening to a podcast, for example, and whenever your gate announcement comes, you can be sure that it's streamed directly onto your headphone, and you don't miss that. As you can see, this is especially interesting also for people with a hearing disability. So that's also one of the reasons why this technology has been pushed very much by the hearing aid industry, and here also especially Sonova. So whenever I have a look in the standards or the specifications of this technology, you will usually also find 1 or 2 Sonova employees among the contributors there. But of course, you cannot only be on the receiving side of a broadcast, but you can also be on the transmitter side. So you can have a smartphone that is supporting the Auracast stream, and you can just stream your audio as a broadcast, and all your friends can just listen in. So no need to share earbuds anymore or something like this. So, but now the question that arises, of course, is how do we actually select a broadcast? Because this can be especially tricky if you're in an area where there are multiple broadcasts around you. So how do you make sure that you actually listen to the one that you are interested in? And this is where the role of the Auracast system comes into play. So this is actually the third role in this network. So you have your transmitter, you have the receiver, but now you have an Auracast assistant. And the task of the Auracast assistant is basically to display the available sources to the user and let them select a source and then provide this information to the receiver so that the receiver can establish the connection, or not the connection, but it can synchronize to the stream of the transmitter. And obviously the first thing that comes to mind here, how to build such an Auracast assistant, would be an application on a smartphone. You can see an example here. So you can imagine it being like a list of, similar to your list of Wi-Fis, where you can choose a Wi-Fi that you want to connect to. The streams can also be encrypted, so you can see there's this lock icon. So if you want to listen to the stream, you would need to provide a passcode in this example. But it doesn't have to be a smartphone application. The Bluetooth organization has also thought of other examples, so it could be an application on your smartwatch, or it could even be such a stylish remote control that you can just attach to a keychain. I think the idea is here that you just skip through the different broadcasts as you would do on your radio, for example. Yeah, although I'm not sure what the target group here would be if you can just have it on your smartphone, but maybe there are people who like this or think that it's more practical. But you can also have the transmitter just generating a QR code directly, so you can just scan it and then also listen to that stream. And this technology is actually already available. So some of the latest Android phones already support this. So they can stream an Auracast, and they can also, they have a native Auracast assistant. So for example, the Samsung Galaxy S24 already supports this, and that's what I'm gonna show you quickly. So what you can see here on the left side is the example where it's used as a transmitter. So you can see these 3 dots up here next to the scan button, and if you tap there, you can see that you get the option to broadcast sound using Auracast. You can select the name and the passcode, and then start the broadcast. And now your audio is streamed as a broadcast, and you will have this notification in your notification bar. And you can also use the Auracast assistant. So if you have a headphone that is capable of doing this, you can just go into the Bluetooth menu. So in this example, it's a Sennheiser headphone here, and you will find, I'm not sure if you saw this, maybe this was too quick. You will see this tile here that says find the broadcast. If you tap on it, it will scan for broadcasts nearby. It's going to list them. You can select one, and now the broadcast starts playing on your headphone. So yeah, when I first saw this, I thought this is really cool. I immediately wanted to try it out. The problem is I'm an iPhone user, and currently there is no support for LE audio on iPhones or on iOS. So yeah, which is a pity. And so the first idea that I had, and I mean, that's the same idea you would probably have as mobile developers, is, well, how hard can this be to build this yourself, right? So yeah, maybe, and that's what's my, the remaining talk is gonna be about. So how can we actually build such an Auracast assistant functionality ourselves. So the first step, of course, is you go, you pull out Google, you read up the specifications, and to save you some time, these are the most important ones if you are interested. So there's the basic audio profile. This is the general profile that's used to define the LE audio functionality, and then specifically for the Auracast assistant, the broadcast audio scan service is of interest. These specifications together have around 300 pages, so there's a lot to go through. If you want to save some time, I can also recommend you this document, how to build an Auracast assistant. It's nicely compromises all the required information. And you will find in there, you will also find this nice illustration. So just to explain again the setup that we have. So we have a transmitter that is broadcasting information into the air, or broadcasting the audio into the air. You have your Auracast assistant, which is connected to your receiver, which is usually a headphone or a hearing aid. And now our task here is to get the information about the available sources, display them to the user, connect to our receiver, and tell the receiver which broadcast it should synchronize to. So how do we do this? So how this works is that each transmitter is sending periodic advertisements. So these are packages that it sends out that contain all the information about the configuration of this broadcast source. So it has exactly the information, how many broadcasts are there, what language, and so on. And this is what we need to scan with our Auracast assistant. So we scan for these advertisements, we parse the information in there, and we present it to the user. Now the user is able to select the desired source. And once we have this information from the user, what we need to do is now tell the receiver, hey, the user selected this broadcast, please synchronize to it, and then the receiver will synchronize to this broadcast. So the transmitter and the receiver are not connected, but the receiver is synchronized to the audio stream. And after this, the assistant is basically out of the game. You can put your phone away, turn it off, whatever, the stream will continue. So let's have a look at what exactly the transmitter is advertising. As you can see here, we have something called a broadcast isynchronic group. So, and this group can contain multiple broadcasts. So each source can actually stream multiple broadcasts. A broadcast is named here a broadcast asynchronous stream. And you can see we have two of these. And for example, there could be a television that is showing a movie, and you could have the audio signal of this movie in different languages. So you would have one broadcast that's in English and the other one is in Spanish. And then each of these broadcasts itself can also have multiple streams. So again, in the example of the movie, your movie is usually a stereo signal, so you would have a signal or a stream for the left channel and the right channel of your movie. Okay, so this is the information that we can get from the advertisements. It's listed exactly in the specifications, like how the structure of this data is and how you can parse it. We're not going to go into too much detail here. But we know this is how we can get our information. Okay, so once we have this, now the next task is we need somehow to show this to the user, as I said, and then tell the receiver about it. So how do we tell the receiver about the broadcast that was selected? Before we go into there, I would like just take a step back for a minute and talk a little bit about Bluetooth Low Energy and how it works in general. So Bluetooth Low Energy, and specifically here this generic attribute profile, were developed for the use case where you don't have a continuous stream of data. So as you would, as you are used from the Bluetooth Classic connection, where you have your headphone connected and you have a constant stream of audio data. This is more for use cases like wearables or sensors, which have limited power resources. And there you only want to read maybe a value every second or a couple of times per second. And for the rest of the time, the actual Bluetooth radio can be in sleep mode on these devices to save power. And this is exactly what we are using here. So when you connect to such a low energy device that is implementing this profile, what you will see is that there is a so-called generic attribute service, and this service has characteristics. And a characteristic is basically the value that you want to read. So imagine this being a heart rate sensor. It would implement the heart rate service, and the characteristic would be actually the actual heart rate value of your device. And a characteristic can be readable. You can also subscribe to it to be notified when it changes. And some of them are also writable. So you can also provide some configuration, for example. And here you see a quick example of, it's actually from a BLE scanner app. You can download it. It's called NRF Connect, but there are plenty others. And you can just go in there and then see at the services of your Bluetooth Low Energy device. This is an example of a device information service. So as you can see, every service has a globally unique UUID, so it's standardized. And that's how this app exactly knows how to interpret this data. So you can see here an example. This is the device information service, and it has 4 characteristics that are listed here, which are the manufacturer name, model number, serial number, and hardware version, for example. So with knowing this, we can go back in our specs and see, okay, what does our receiver provide us? And you will find something called a broadcast audio scan service. That's also the one that I've listed you before or shown you before. And there's a characteristic called broadcast audio scan control point. And this characteristic is writable, so you can actually write operations to it. And one operation that is of interest for us here is the add source operation. And if I just quickly read the description here, it says, requests the server to add information, including metadata for a broadcast source, and requests the server to synchronize to a periodic advertisement and or broadcast asynchronous stream transmitted by the broadcast source. Nice, so this is exactly what we are looking for. So by writing this operation to our characteristic, we can tell the receiver to synchronize to exactly the source that we want. So now if you take a closer look on how this operation actually looks like, you're gonna see there's a bunch of information about the advertiser, like for example, the advertiser address, which is just the MAC address of our source, and things like a broadcast ID and some metadata that can be provided. But basically it contains all the information that we have seen in this picture before. And there's also 2 fields that are actually we can use to tell the receiver if you want to synchronize or maybe unsynchronize from the stream. And these are the periodic advertisement sync and the broadcast asynchronous sync fields, which are marked in blue here. And when we write this information, what happens is that the receiver will update another characteristic, which is called the receive state. And there can be one or multiple receive states in each receiver, and each receive state represents a source. So this would basically contain the information. This receive state would contain the information about the source that we have just added. And you can see it's mostly the information that we have provided initially, plus some additional information like the encryption state. All right, this is pretty much what we were looking for. So we know how we can scan for sources. We probably know how to display something on our app and let the user make a selection. And now we know how we can provide this information to the receiver. So let's start coding. So the first thing you should probably do is pick the BLE package of your choice. What I can recommend, what we are mostly using is the Flutter reactive BLE package, which is developed by the Philips Hue team. And what you will find there is a method called scan for devices. So because we want obviously to scan for our sources. And this method will return you a stream of discovered devices or discovered device. So let's have a look at this discovered device class, because this should contain all the information that we need about the source, right? So you can see here we have an ID, which is the MAC address. We have a name, and we have this field, or we have this map called service data. And I can tell you this contains all the configuration information about our source. So there, for each service, it contains some structured data that we can read from here. But maybe you remember we saw something called advertising set ID, which is required for at source operation. And interestingly, you won't find this in this class, which is strange, right? Why would this not be available? So maybe we can just check the native APIs to see if it's available there. So if you have a look at the Android Bluetooth API, we will find something called get advertising SID. So this is exactly what we are looking for. So let's have a look on iOS. Well, I can tell you won't find it. It's just not available on the iOS Bluetooth API, which is strange, right? But it's just not provided, so the core Bluetooth interface of iOS does not provide the advertising set ID, and there's something else. Even the ID that we saw of the discovered device is actually not the MAC address on iOS. For privacy reasons, iOS is hiding the actual MAC address from you, and it's just providing a device-specific UUID. Okay, that's too bad, right? It looks like our small little project ended before it really started. But yeah, I think we're not going to give up that easy, so maybe let's have a look again at our specifications. Maybe we can find something that can help us there. And actually, there is a document which is called Developing Auracast Receivers with an Assistant Application for Legacy Smartphones. Well, I wouldn't consider my iPhone to be a legacy smartphone, but let's have a look. Maybe there's some interesting information for us. And actually, what you will find in there is this, and I'm just going to read it for you. So, to operate with an earlier generation of smartphones which don't support scanning for advertisements, we have to move the scanning task to the Auracast receivers. All Auracast receivers must be able to scan for these advertisements. That's a mandatory requirement in the basic audio profile specification because they need to be able to work autonomously. Well, that's interesting. So the receiver itself can do the scan. So we can actually outsource this functionality to the receiver. It further says, to use an older phone to display multiple Auracast broadcasts that are available, an Auracast receiver needs to perform the scanning function and make the information it finds about the streams available to an application on the smartphone. It stores the information in a new broadcast receive state characteristic, which it creates and notifies it, allowing the phone application to replicate and display the list of Auracast transmitters that the earbud has found. So this is exactly what we're looking for. So the receiver can do the scan for us and then just add these sources to its receive states, and then we can read these receive states, we can show them to the user, and then let the user make the selection, and we only provide back to the receiver the information of which of these sources the user has selected. All right, so I think we saved our little project, and we are just going to use this little workaround here to implement this functionality. So again, we're going back into coding. We're doing the scan again, but this time we're not scanning for sources because that's what our receiver will do for us. But we still need to connect to our receiver first. So before we can connect, we need to scan for it. So we scan for our receiver. Once we have found it, we connect to it by using the connect to device method here. And the first thing that we do once we have connected, we run a service discovery because we want to find our broadcast audio scan service. When we have found the service, we need to subscribe to the receive states because we want to be informed whenever the receive states are updated. So we are looking for our broadcast audio scan service, and then within this scan service, we look for the receive state characteristics. Once we have them, we subscribe to them to be updated whenever they change, and we just keep a list of receive states that we update and display in the UI. Now the user is able to select one of these receive states, and when he selects it, so we either synchronize to this broadcast, or if it's already selected, we just unsync it, so we deselect it. And in order to perform this, there's this there's another operation that we can use, which is the modify source operation, and that's what we can see here. So whenever the user selects or deselects a source, we just create this modify source operation. Then, depending on if we want to sync or unsync the broadcast, we just set the BIS sync and the PA sync field here accordingly, serialize the whole thing, and then just write it to the characteristic. And that's basically it. So in the end, it's pretty simple since the receiver is doing the scan for us. And yeah, I've actually created a little sample application. You can find it on GitHub. Yeah, you can check the source code. So there's no, it's all just a standard BLE services. So even if I'm just gonna use a Sennheiser headphone here now, you can be sure that I didn't use any custom or proprietary interfaces here. And yeah, I'm actually gonna do a little small demo here. I'm gonna be daring enough to do this. So just give me a second. Just gonna play some, there's now some advertisements here. Okay, so let's just so I have my application that I'm starting here now. It's scanning for receivers. Maybe what I need to mention first is, so I have actually a Bluetooth dongle connected here to my laptop, which is Auracast capable, so I can just select it as audio output source here. So whatever I'm playing on my laptop now is gonna be broadcasted as an Auracast. And I have these Sennheiser headphones, which are Auracast capable. And, oh, you're not seeing it on the screen. Just give me a sec. Okay, where's that? Yeah, okay. Okay, there we go. Okay, so I'm just taking out my headphones. I do the scan. I found my headphones. I just tap on them to connect to them. And now I can actually start an Auracast scan by just doing a double tap on my headphone. You can see it found this little dongle here. It's just showing the MAC address because there is no way to assign a proper name to it. And now I can select the source, and you can see that it's synced and playing. It's also, I'm not sure if I can hear that. Probably not, right? You just have to believe me, that's actually playing. But yeah, now we have built our custom Auracast assistant, and it's running on an iPhone, as you can see. Great, this is what we wanted to achieve, right? So just coming back to my, thank you. So just coming back to my presentation now. So we have it running on our iPhone. It's great, that's what we wanted to achieve, right? So now we can do the same on Android, I guess. Yeah, that's what you would think, right? But then if you try to run it on Android 13 or higher, what you will actually see is this. Need Bluetooth privilege permission. So it turns out the Android team has restricted the access to the services that we need only to system applications. So no third-party applications are allowed to access this. You can check also the source code on Android, and there's a list of these restricted LE audio services, and you can see our BASS service is listed there. I also had the chance to get this to ask somebody from the Android team on this and get this confirmed. So this was the answer. While the team wants to provide flexibility, opening up certain things to all developers has created complexity in the past and block certain changes. Since we need to maintain backwards compatibility, the team preferred closing down this to system apps only and unified the UI and avoid fragmentation. This is work in progress. Okay, so unfortunately, we are not able to use our nice Auracast application that we have just built on Android 13 or higher. So this leaves us with the following situation, just to sum it up again. If you are an iPhone user, or you have an Android phone with Android 12 or lower, you're lucky. You can use our nice little application that we have just built and run it on your phone. If you have an Android phone, which is running Android 13 or newer with the native assistant, so the native assistant what we have seen in the beginning, where it's already implemented natively on the operating system level, then you're still lucky. You can just use the native assistant. But if you have an Android phone with Android 13 or newer, without the native assistant, well, I guess then you're in the target group for this little gadget here. So now it all makes sense, right? We found the user group. There's still one other option. Obviously, you can still hope that the manufacturer of your headphone actually provides its own Auracast assistant. And I can tell you that's exactly what you will see if you buy a Sennheiser headphone. So you can just download the Sennheiser Smart Control app, and you will see that we have implemented a custom Auracast assistant there. So yeah, you're safe. You can just use it with every phone, as long as it's capable to run the Smart Control app, of course. Yeah, this is basically the end of my talk. Just one more thing. So if you found this stuff interesting and you would like to work with that, scan the QR code. We're looking for Flutter engineers. This will take you to the job posting. Thanks a lot.